Welcome to those of you here in our auditorium, and also welcome to those of you who are joining us online today. So today is another special day here at UCLA. We have our Data Theory in the World seminar. Why is it important to be a data-driven organization? Today's panel features leading data scientists from Capital Group and KMPG. Welcome. My name is Miguel Garcia Garibay. I'm the Dean of the Division of Physical Sciences and also the Senior Dean of the college here at UCLA. And it is a real pleasure to welcome you to this panel discussion. So in my role as Dean, I get to interact with many departments in the physical sciences, and two of the departments that really are generating a lot of excitement in the last several years are statistics and mathematics. As many of you know, actually, statistics really was created at UCLA as a discipline that is heavily based on computational approaches to statistics. So in a way, our statistics department was a really an early leader in the development of data science per se. So to recognize that, in fact, it was just very recently that the UCLA Academic Senate decided that it was fitting to change the name of the department from the Department of Statistics to the Department of Statistics and Data Science to recognize that very fact, which I think is quite appropriate. Now, on the other hand, as many of you know, the applied mathematics groups has really rose to the top of the rankings in the nation, and they have been doing extraordinary science, which has a significant overlap in the directions of data science and a lot of what it implies. So it should come as not surprise to anybody, I think, that the opportunity arose for have our math and stat departments to come together and really become, in a way, leaders in the field and articulate an idea and a concept that we find extremely compelling, and that is developing and going deeply into the theoretical basis of mathematical models and applications so that we can really understand what's under the hood on all of these methods that work so well, get so sophisticated and so successful, but seem to carry a certain level of empiricism. So I think, this is I find it an extremely compelling concept to bring statisticians and applied mathematicians and really look at the problem of, how does this really actually work? What are the principles behind it? So now what that does is that UCLA students have the option to center their studies in a wide range of tools and applications in the Department of Statistics and Data Science, or to immerse themselves into the mathematical foundations of those rapidly evolving methods, and they can work with faculty from both departments by pursuing a data theory major. So I think that is something that is quite unique at UCLA, that a group of students can really go more into the foundation or really go more into the applications, and together perhaps develop the new methods that we're going to see in the future. Now, as I was coming here today, I came to the realization that this is the second year we're hosting the Data Theory in the World seminars, and the objective of these lectures and panel discussions is for our students and the members of our community to learn about the impact of data science, the impact that it's having in various industries, and how it creates a positive change for the world. So we would like to thank the members of the Data Theory Board of Advisors that are present here today, Sandeep in particular, for their continuous guidance in our curriculum and for helping us bridge the gap between UCLA data theory and industry. So with that, it is my pleasure to invite Professor Mark Hancock, who will introduce our moderator, panelist, and event here today. Please, Mark.
I'd like to thank the Dean very much for the introduction. This is the third in the series, the Data Theory in the World seminar series. The series itself is organized by the board, the advisory board for data theory. And the board itself is comprised of a very diverse group of individuals from industries that have been transformed by data science. So it's a great opportunity for us to hear what it's like to be a data theorist in the world. I'd like to introduce the event moderator, Sandeep Bhasin, who is the Senior Vice President and Global Head of Client Data and Analytics at the Capital Group of companies. His education featured a Bachelor of Science in Information Studies, and he has worked extensively over the last years becoming a data scientist as the entire field of data science was transformed at the same time he was learning it. So he's been on the advisory board and played a very active role. So we're very happy to have him as moderator for the panel today. So welcome, Sandeep.
All right. Well, thanks for joining, everyone. Maybe I'll start by introducing our panelists. And so Mark just did an introduction for me. As he mentioned, I work at Capital Group. Alongside me here, Rick White, who has recently took a new role, a broad role across Capital Group, leading our enterprise data office and really heading up all of our data initiatives across Capital. And Rick can certainly expand a little bit on that. And then at Capital Group, we do quite a bit of work with KPMG, and so we reached out and asked Danielle to join us from KPMG. She was previously Chief Data Officer for Nissan and had a number of other roles in industry. And she's also joining us, bringing another perspective outside of Capital Group, because we have a condensed perspective between Rick and I. So with that being said, I think we'll, I don't know, Rick, if you wanted to add anything else to your intro and background before we get started?
No, I think we can.
Okay, sounds good. Why don't we dive into it? So I thought what we'd start off with today is really just to get everybody grounded on the term data-driven organization, and we've seen that evolve quite a bit over the last 10 plus years. So maybe we can just start off with each of your perspectives on how, what's your perspective of what it makes up a data-driven organization and how you've seen that evolve over the past, and we can just box that into the past 10 years. So Danielle, maybe we start with you and then we'll transition to Rick.
Yeah, sure. So really excited to be here. Thank you for having me. I'll try to talk as loudly as possible, not overwhelming. So when I think about a data-driven organization, the first thing that comes to mind is thinking about data for value, right? So many companies struggle with how to position that properly when they are thinking about their software development lifecycle or how they want to meet their business objectives. In my mind, I see data as the bridge between the business and technology teams. So the language with which people are communicating about data, how they're making it a priority in their organization, has changed dramatically over the last 10 years. I like to say that people need data therapy so that they actually can work correctly together and think about data as a product, which we certainly will talk a little bit more about tonight. I also think it's a complete refactoring of how people do their jobs. So if you look at the ways in which open source, the availability of cloud technologies, has democratized the availability of technology. So in the late 80s, early 90s, if you didn't work for a large corporation, you did not have access to enterprise class, enterprise grade databases, software solutions. And now, in about 15 minutes, any one of you could log in, create an account on any one of the hyperscalers, and go ahead and start some Spark jobs and actually do coding, like literally within 15 minutes on a credit card. So I think that's changing how people think about data, and that it is accessible to everyone. But then you have to start to think about, what persona am I going to be in? Am I going to be a data scientist, an analyst, an engineer? There's so much opportunity there. So I think those are the big drivers around being a data-driven organization that have dramatically changed things in recent time.
I love that as a start, and as I reflect on my career, what I would offer is that we've seen three arcs so far in what we think of as a data-driven organization. So the first arc, for a great number of years, we were focused on process optimization. So you think of like the large-scale enterprise resource planning, supply chain optimization, manufacturing, engineering processes. And
Thank you. So maybe we'll shift on, and we had a number of questions from sort of leading up to the seminar. The second one that we have, and this gets a little bit to Rick, and I'll let you take this first, is the sort of topic of competitive advantage. And the question is as you think of, maybe I'll just tune the question a little bit based on what you just said, is as we think about competitive advantage, and the question's more around the relationship of data science, which is an emerging area that has emerged quite a bit lately, and marketing, which has traditionally and historically been a data user, consumer, to help execute its activities. How have we seen the relationships in the organization, and it could be more than just marketing, but let's take those two and add to it as you see fit, have changed over the last decade? So as you see the interactions evolve, what have you seen over the last decade on that front? I think we're having a little mic
Some
problem.
mic issues. You can all hear me?
Yeah.
So this is a question, of course, that's near and dear to Sandeep's heart. So he seeded the questions in the panel because he comes from a client group analytics background. So, naturally, the reality here is that the evolution we've seen is that sales and distribution, and the relationship with marketing was the first and the most important relationship that sort of creates a backbone for answering this question. The fundamental premise behind the sort of field sales force and their meeting the streets and knocking on doors is an information advantage, right? So it starts with this notion of who are those likely customers to buy? Who are those best leads? How can I build a relationship that exploits what they need relative to the product that I'm offering? And so in some respects, the role of marketing was more so in product design, and it was reactionary in nature. It's often described as the tail that wags the dog in some respects, right? That's changed fundamentally now because it's no longer true that the information advantage is gained through that interaction in the field and in that street. The economy itself has created so much digital data as currency that's moving through there that data science has now become the competitive advantage of most marketing departments. Their ability to design complex segmentation, methodologies so that they can better understand their customers, their buying preferences, how they relate to one another in their purchasing decisions, their ability to then tie that to product recommendation and how they recommend next best products and actions, particularly in a digital environment, has really changed that dynamic, particularly as more and more sales have moved online and moved more digitally. So there's not, in all cases, necessarily that individual salesperson who's involved, right? And so I think what we see is we see the shift in that in marketing, that marketing departments have grown in their importance across any firm, not just in product design any longer, but really in all approaches to how we think about commercialization opportunities.
Yeah, and maybe Danielle, as you kind of think about that and answer that, feel free to take it the same direction, or with some of your past experience at Nissan or elsewhere, I'd love to get are you seeing it the same way, or is it different? In some of your
It's been interesting. I think there's two parts to it. The first would be, at least in automotive, a lot of the sales and marketing was outsourced to agencies and partners. And I think there was a movement really over the last few years that a lot of corporations want to insource that. They want the data to be closer to them. So really get that data gravity where they're building that customer 360 view, not only to understand the customer, as you said, but the other part of it is the marketing organization had to be far more aware of customer sentiment and overall customer expectations outside of their own product range. So as customers were doing shopping on Amazon, as customers were having digital experiences in stores, physical stores, that imparts a way that they change their expectation about how they want to shop for a vehicle or how they want to buy a product. So I feel like the aperture of what marketing actually cared about and needed to look at was much wider in a digital age where that data, the proliferation was everywhere. And then it kind of comes full circle around personalization, right? So they need to know not just your habits within the products that you're selling, but what you want around that. And I think that became a really interesting competitive space. And then drove the the types of data science projects you would see. That even extends to product design. So it moves from a marketing motion where you're understanding the customer, you're drawing in the customer based on their preferences, but then that goes into your actual product that you're selling. And so we were seeing a lot of that marketing data, the interaction with the web and with any type of personalization experience actually go back into product planning for vehicles in the case of Nissan, right? So that you're closing the loop on a circle that sometimes was very isolated in silos, and that data was really the tether across business areas that maybe previously didn't collaborate around data. So it became that collaboration plane. It was really interesting.
That's great. And maybe we'll keep it with you, Danielle. And the next question, and you talked about data as it kind of is rapidly being produced and created, and maybe this is a good segue into, in order to actually make use of that, you need to prepare that data, and you need to kind of make it in a good way for the analyst, data scientist to use it. So a question that had come in, and it's connected to that, is what do you think are some of the most important technical skills as folks who are interested in this career long term should prepare for as they move forward?
Oh, I love this question so much. So I have I've been saying it a lot lately. I think that traditional data architecture, as far as logical and physical data modeling, canonical models, ontology and taxonomy about how data is described, classification and labeling, is truly having a renaissance. And the reason for that is many data science teams have invested a lot of time and energy only to find that the outcome of their models and what they thought they were going to get really was underwhelming, whether it simply didn't hit the mark, or it went in a completely different direction, or maybe the contextual, understanding of data was missing. So I think that that's a really important, what happened when a lot of organizations were moving their data warehouses or operational data stores to the cloud, they thought, oh, I don't need to model my data anymore. I'm going to do ELT. I'm just going to stuff it up into the cloud. I'll figure it out afterwards. Well, people were finding, and that's why, data lakes turning into data swamps was a thing. There simply wasn't the rigor up front. And I think there's a big transition now where data architecture and data engineering are unified. But I think the relationship between the data scientists and the data engineers, I call it like the salt and pepper of doing data properly. They should be connected at the hip. As far as technical skills, so beyond traditional data architecture discipline, data integration understanding. So anything related to APIs and microservices. And consumption of data in that method, not just in a traditional way in tables, or whether structured or unstructured data. And I think deep domain understanding. So the data itself, wherever it is residing, really has to be well understood. And I think people maybe take shortcuts when it comes to business glossaries and understanding of the data utility. So I would say becoming very, very skilled in understanding the data utility, where this data should be used for this purpose, but never for that. That also is extremely important when you begin to do data exploration and you're doing feature engineering. You're blending data, third-party data that's outside of the control of your organization. You might not know the proper way that should be intersected to your in-house data. And then I think everyone should be very familiar with and constantly on the pulse of what's coming in the cloud-native stack. So for all of the hyperscalers, it's very easy to review, what are the types of services that are out there. All of them are in this competitive cycle where Google will announce something and then you'll see AWS follow very shortly after, and it drives a huge amount of pressure on the tooling too. So if you look at like the data science tools that are out there, as well as data integration tools, they are constantly upping the ante to be at parity with one another. So I think being very attuned to what's out there, the interfaces that people are going to use to do their job. Certainly, I'm a big advocate for Python and R, absolutely, always will be. But the tooling that augments that allows you to move faster with your data integration, I think that whole stack is really important for people to be very skilled at.
Before you hand it off, Danielle, just one thing, because I'm not sure the audience will know the term hyperscaler.
Oh, sorry. So the cloud providers. I'm sorry. Azure, Google, AWS. Sorry about that.
No worries.
CSPs are hyperscalers. Yeah.
Sounds good. Rick, maybe you can add that your perspective, whether it's similar or you're seeing some differences as well.
So Danielle's answer was fantastic. I don't want to repeat a lot of what she said. What I'll offer again is a commentary on the the change in the technical skills that have been required of our teams, and then what stays the same as along with what changes. When I started my career, I didn't know this yet, but I learned very quickly that I thought in SQL. So listening a little bit more recently about mental visualization and other techniques, and I learned very quickly that similar to language, when I was thinking through data, I was able to construct pretty complex, concepts and thoughts in structured query language or SQL, which has been the lingua franca of data for, effectively the past 30 years. Right? Now, I mention that for a reason. The reason is because something that Danielle said is very important. This renaissance that she talked about in data modeling and this notion of having structure in our data depends very greatly on our language around data. So if you connect the two, my language for data was SQL. The way I interacted with it, the way I expressed it with it was that. And that remains in many cases the same thing today in a lot of ways. It allows for people to think in structured ways around how they optimize data in models. And it's made even more powerful the more ubiquitous it's become. So whether it's a data frame in Python or whether the newest technologies, I would argue, that have gained a lot of traction is one's called DBT, which is one that allows you to express transformations in SQL. She used a term that some of you may or may not be familiar with, this notion of ELT. ELT is a reaction to the classic paradigm of extract, transform, load, which is sort of by definition the primary way that we move data around and that we change it in order to move it to the right place where it's being used. The backlash that came with the cloud that Danielle mentioned was, well, we don't need to, the idea was that it was a schema on read. We don't need to impose a structure. We don't need to be, in effect, biased about what the structure of the data should be before the use cases are clear, before the user is able to do that. Now, the point that she made, in fact, was that in some ways that's become less true, and partly it's because of our need to govern that data. And without some of the structure, we lack the language in order to do that effectively across a really diverse organization and across different parties like regulators or clients in that regard. Right? So in addition to all of the cloud-native technologies that she referred to, which are as moving as fast as anything I can recall in my career, between Snowflake, Databricks, the largest out there that are consuming a lot of bandwidth as we move forward. I think that foundation in SQL, that foundation in data modeling, and that foundation in Python, which has quickly surpassed even R as the primary modeling language for most data science, has become among the most critical skills.
Well, maybe just kind of a little opposite of that question, one that came up for us as we were kind of preparing for this was, is there anything that people have done in the past 5 or 10 years they need to unlearn as they evolve in their careers? So, the question came in around a data scientist, and the thing I think about from a data scientist, they spend a lot of their time, probably an inordinate amount of their time preparing for data. And preparing the data to be able to develop models and algorithms and just statistical models, et cetera. So maybe just, if either of you want to jump in on this one, is there anything you would say that they shouldn't be doing going forward and you kind of have to unlearn?
I'll offer a tongue-in-cheek answer. Excel is the most powerful analytics tool ever created. And I think we need to unlearn it. I mean that in a lot of ways because I watched it over my lifetime, right? That transition between the early generations of spreadsheet technology like Lotus 1, 2, 3, and it literally transformed the workforce. Excel became the most common skill across so many different categories of job families that it revolutionized the way things were done in so many different ways. Now, the problem is what Sandeep described, that tomorrow's application of data on on a commercial scale, on a hyperscale, as Danielle mentioned, it can't be accomplished in Excel any longer. And in fact, Excel is that limiting factor. Data that's locked in spreadsheets has quickly become a risk area in a lot of different organizations. Okay, so now let me walk that back a little bit, because I feel the same way about Excel that I feel about SQL. Our ability to think through data in grids, and our ability to think through the language that we use to compute and calculate analytics in Excel, and the way it shaped our views on visualization is somewhat unmatched with any technology that we've ever had. In fact, we probably still say on a regular basis when somebody's designing an application, don't recreate Excel. It's too complicated. Don't even try it. It already works so well for what it does. So that's why I call it a tongue-in-cheek answer. I don't really mean that we need to unlearn Excel. What I mean is, in practice, that we need to use Excel for what it's best at, and rather than using it to do a lot of manipulation and wrangling of data, particularly to feed research and development processes and data science processes, we need to walk that back. We need to use it for prototyping, for visualization, for sharing of figures and numbers in a variety of different forms. And that's one that occurs to me that we can characterize that way. What do you think?
I really like that, by the way. Totally agree. I would say don't do your data in Excel. I would agree with that. A few that I have observed over 30 years in information technology or information systems, I'm going to say ITIS, and that's what I mean by that. I would say don't work in isolation. My observation is that a lot of the data scientists I've encountered, they are embedded in the lines of business, as they should be. They're not normally part of the IT or IS organization, but they almost do like an ivory tower. I don't know if it's because it's the domain specificity of the data. They've been tasked, with probably being one of the only technical people sometimes in a team, right? And they're looked to as that technical subject matter expert. But often they forget that there's an entire technology organization that's the one actually providing them with the data. So I would say use the bridge of data between the business and IT, because that's the best thing you can do. I would also say data science and data engineering is a team sport. And I have seen organizations that have communities of data scientists working together and data engineers. They are many degrees more successful, because when the data scientists are working in isolation, they're all doing the same work repetitively and they're not talking to each other. And it's a huge waste of money for the organization. And then you're just losing all of that creative opportunity to really be curating data, to really be getting models out there. I'm sure you all have heard the statistic that very few models actually make it into production. And I think it is attributed to sometimes isolation that happens in that realm. The other thing I would say is going forward, this isn't so much a don't do it, but going forward, there are so many more opportunities to use synthetic data now for machine learning training models. Please lean into that, because it is the future. So synthetic data, differentially private data, is absolutely an avenue for people to dramatically improve the speed to insights and basically generate unlimited data. I call it data vegetarianism, because it looks and feels and has the same statistical distribution as the original data, but it's safe. You've removed any data that cannot be shared, whether it be PII or private data within an organization. So I would say explore the newest techniques in generative AI to assist with the process of doing machine learning models.
Well, thank you. And I heard you both say a lot of good stuff. So the next couple questions, and we'll maybe break these up. But maybe Danielle, you could cover a little bit about, you talked about how critical it is for a partnership between technology and engineers and the data scientists. And I think one of the things I mentioned early on is that we want to try to move away from having scientists doing a lot of that engineering type work. It's actually something Rick and I have been thinking a lot about at Capital. But maybe you can just talk about what does that data preparation integration mean in the real world? And then Rick, we'll pivot over to you to talk about data governance, something that you love to talk about.
Yeah, so data integration in the real world looks, I'll kind of walk through really quickly what that looks like. So the first is having a really good understanding of the data inventory. So whether you're working in a small business, large company, understanding the data that's actually available in the catalog, whether that's a formal data catalog or not. And that hopefully that data is profiled. Hopefully scorecarded as far as data quality goes, but having a really clear context for who does what. So kind of persona-based design, right? So what is the data engineer going to perform? What is the data steward or data owner going to perform? How is the data scientist going to be waiting for the data that they need to be made available for them? Well, that definition has to be done through some sort of an intake process. So we with our clients and my role as a CDO, there should be a data discovery process. It should always start with that. That's where you're identifying the need and the data utility, what data is needed, you know, any of the role-based access controls, what is it going to be used for? You know, is that data to be normalized or denormalized? That discovery process is a really important part of the analysis, and I actually believe that multiple people, I say it's a team sport, should be involved in that up front. The data scientist, the data engineer, usually there's some analysts that are involved, a DBA, depending on, you know, if you're doing cloud work, it could be a cloud engineer is involved. The data integration itself is the most important thing I think to think about there is this a B2B or a B2C? Like, what is the application integration needed? Is it going to be a transactional application that is generating the data that then is going to be consumed? Does it need to be exposed outside an organization through APIs or microservices? What does the data exchange look like, right? Is it going to stay inside the perimeter of the company, or is it going to be moving outside? So all of those things have to be considered up front in the data discovery. And what that does is that actually allows you to plan your resources, right? You might not need a data engineer until 4 weeks in. You might not need a software engineer to begin developing an application until the data product is ready. So if you think about the way you organize a software development lifecycle or way you organize a data product lifecycle, if you don't do that work up front, you really aren't prepared for the investment you need later, especially if you're going to be procuring services or storage and compute in the cloud for data integration. Let's say you want to do an API gateway and expose all of these great new data products you developed for your organization. You have to think about security. You have to think about what you're going to be paying for that storage and compute in the cloud. So those are all these data integration topics. They can be very expensive. So some organizations have gone into the cloud, they've set up their data pipelines, they're really excited because their data is landing in the cloud, and they're going to have a way for people to access it either through a sandbox or through some, you know, data science tool, whatever it may be. And then someone leaves a long-running job on overnight. We call that leaving the oven on. And then their organization the next day gets an alert at the help desk that a $50,000 virtual machine was running all night long on a machine learning model. And everyone's like, wow, that was really bad. So that's why it's important.
And expensive.
And expensive. And then after someone gets fired, no, I'm just kidding, hopefully not. But that's why data integration matters, because it's not just working locally. My point is, it's not just working with Excel on your laptop anymore. As soon as you go to the cloud and you start provisioning infrastructure there, you have an additional functional and operational obligation that you never had before. So if you look at software engineers, data scientists years ago before cloud, like when you're in a legacy bare metal servers, they can run all night. Nobody cares. It's a little bit of electricity. There's probably somebody in the data center. But when you go to the cloud, you actually have to expand, I'm not just a programmer, but I need to actually really think about my deployment, my services, what is running. And I think that's actually changing the skill set and what people have to consider that they never had to do before. And it's not just going to be cared about by a cloud engineer. It's actually going to be, you know, important for people to have awareness of that. I think that's a key thing for data integration, what I call in the wild, in the real world, because it can be an expensive mistake, and you have to be operationally aware.
So Rick, as you kind of take that as a follow-up, because all that really doesn't work unless you're able to measure the quality and effectiveness of your data. So maybe you can talk about data governance and even data quality and how important that is into the ecosystem, you know, thinking about what we've been talking about actively at Capital and how important it is, but I'd love for you to spend a couple minutes on that.
Absolutely, and I love what Danielle said. Maybe I'll just riff off it a little bit before I go there, which is one of the skills we didn't talk about that she alluded to was this notion of cloud engineering skills. Containers is the new model for deploying anything, and it's such an important skill. It's no longer an infrastructure skill. It's just as easily a data integration skill as others. So just a small point there. Data governance, like any governance, across, our government or anything else, starts in many respects as a control function, right? And that has its positives and its negatives. So I think in part, by virtue of how I described that data-driven organization earlier, right? What we need to shift our mindset on data governance is that it's actually an enablement function. Data governance enables trust that enables us to leverage data in a competitive way with confidence quickly. That's really important because I can't tell you how often we spend inordinate amounts of time debating whether or not the data methodology is correct, whether the source is the correct one, how it's being deployed at different sort of business uses and otherwise, right? And with the right data governance and the right decision making up front, you can wipe out a lot of that churn, wipe out a lot of that mess. Now, data quality in some respects is the new information security. It has reached a point where it's so critical in business enablement that it's on more of a C-suite, agenda. This was true of information security over the course of the last 20 years, right? You had to know it as a CEO because the odds that you were going to be in the newspaper, were rising dramatically, right? And with data quality, the same thing is becoming true, right? Because of relatively high profile, data quality challenges and hiccups, right? And so one way I like to think about the relationship between data governance and data quality, right, is if data governance is designed to get you to the point where you have this really well understood network across your firm, all of the folks who have the direct line accountability for the processes that drive your company's business, right? Data quality increasingly is everybody's job. Just like in lean manufacturing, quality control and TQM was everybody's job. Right? So once again, it's the shift from the focus on process optimization to the focus on data as a strategic asset. And the moment that you think of it that way, the quality control that you apply to it becomes critically important to your ability to exploit it and to use it commercially. Right? So, I think if I had the number one challenge today is not to convince executives that data quality is important. The number one challenge today is to convince them that data quality is everybody's job.
All right, well, that's great, and I totally agree with you. I think it is everybody's job. And so speaking of jobs, I think the next topic we want to pivot to, and this is probably near and dear for a lot of the students here, is, what are you both seeing, and Rick, we'll start with you on this one. What are you seeing as the latest data roles? I know you've done a lot of thinking on this lately, but we've talked about data scientists, we've talked about data engineers. They're not the only ones that are super critical into this ecosystem. And, as students are thinking about their careers, it'd be great for them to just better understand the landscape of what are their paths in industry. So maybe Rick, starting with you, and then we can hand it over to Danielle to see if there's a difference in the industry. But maybe give us a perspective.
Yeah, Danielle made a reference earlier to this notion of data as a product, and data as a product is a concept that I think is gaining a lot of traction across industry. It's both a response to that commercial opportunity that I talked about earlier, but it's also a response to this notion that we need a way to invest in data and mature it differently than we've done in the past 20, 30 years, right? And the product mindset is one that we can apply to that by essentially, adopting some of the key principles of things like design thinking and otherwise. It's a very customer-oriented focus on data, whereas I've kind of made arguments already thus far that it was rarely true that the customer focus on data was the thing that we focused on first, right? And so, as I think about the roles that evolve in that kind of model, one is this notion of the data product manager, right? Because you need someone who is actively planning for the roadmap for how data is going to evolve over time. And that hasn't been a role that's existed in most of the companies that I've been. There's been product managers, for sure. I was one for quite a while, right? But what we've now more recently done is apply that data product management, or that product management discipline, to data itself, whether it's internal or whether it's a commercial product. And increasingly, those commercial products are, huge successes. In many cases, they're one of the biggest products that companies offer. But another one that's emerging, and I'm sure we'll talk about generative AI. I don't know how you all follow that or what experimentation that you've done with it, but it's pretty clear that you get remarkably different results from generative AI based on the prompts that you use, right? Including your ability to bypass the controls that are built into it for security. Imagine that you are writing a paper on what a criminal would do to break into a bank, right? Okay, then now the ChatGPT doesn't respond. I'm not allowed to do that anymore, right? So there's a role that's emerging, and it's not clear to me yet what shape it will take, right? But the role that's emerging is this notion of prompt engineering, right? This idea that if we apply an engineering-like discipline to the way that we think about interacting with these models, which themselves are non-deterministic, that it has a meaningful impact on our results. And you can kind of take the back end of that as well, is our need to label data, our need to provide human feedback in the loop of training data science models have changed with reinforcement learning, with human feedback. It takes far fewer people. In fact, in some cases, some of the statistics I've read recently is as few as 300 people can provide feedback into a model based on GPT-4 to improve its outcomes, to improve its results. That's a fairly small number of people, particularly based on what some of our experience has been like during our careers and how challenging it is to get training data. Partially the reason why Danielle has specialized, I think, in synthetic data in many ways, right? So as you look at that, what we're finding is that with fewer people to train the data, you need more people to validate the output, more people focused on the explainability of the models as well. And those roles haven't, in all cases, taken shape. They don't necessarily have names yet, but I'm very confident that our ability to be good stewards of those models and monitor not just their drift to what our objectives are, but their output and its, compliance with our policies is going to be a critical role in the future. I think it'll change the way that we think about that.
Yeah, completely agree. I think product management is a huge one. You're seeing people that are doing data as a product. They're doing, honestly, just product management for any software product that they have, not just a data product. I would say we see a big emergence in any of the ops. So machine learning ops, data ops, all of that. That is a huge opportunity. And I think it's driven through data observability, which is an emergent discipline. Around the telemetry and the use of active metadata to observe data pipelines, to observe data movement, and to identify data quality with an AI/ML assisted telemetry. So much more predictive in nature, more proactive than reactive. If a data pipeline breaks, or if the shape and size and behavior of data changes dramatically as it's coming into an organization, you can really identify outliers quickly. There's a lot of products in the market, but people are really getting into, DevOps has been around, so obviously DevOps engineers, that there's a huge demand for that. ML ops and data ops. I would say the other thing, which is the parent of synthetic data generation, which is privacy engineering. So privacy engineers sometimes are coming as a offshoot of cybersecurity. but also just from a, privacy by design, the discipline of enacting privacy in every step of a software development lifecycle or a data development lifecycle, meaning don't do masking and obfuscation of data later. Do it at the very beginning before you even source it the first time. So I think that's a really interesting discipline where we're seeing a lot of demand as well.
That's great. So maybe we're going to just pivot. We have a couple more questions, then we'll turn it over to the audience if they have any questions. But given you both talked about some great roles and opportunities as students are looking forward and helping them kind of find one of those paths or be able to move between paths. And is there anything you'd recommend from encourage students to kind of do some sort of experience as they're in their learning journey to help them with this transition?
Yes, do every hackathon you can. So if you have an opportunity to work collaboratively with other people, either virtually or in person, that's one of the greatest ways to expand your skill set and actually try some really challenging either domains of data, and just really be exposed to a wide breadth of opportunities. I would say be very active in other people that are in the same pursuit. And I was telling them before this, as far as like what not to do, there is no wrong choice in your path around your career choices. The only thing you don't want to do is don't stay somewhere too long if it's not working for you. And you clearly know it's not, it is not a trajectory you want to be on. And that's a really difficult choice. But I do see people in every technical discipline staying way too long when they really know they're not growing technically, they're not growing professionally. I mentor a lot of people, so I would also say, have a mentor, be a mentor. I think I credit, I started out as a programmer, I was a software engineer, and then moved into technical leadership of teams. I absolutely believe that having strong mentors and having connection to peers and then mentoring other people was one of the single biggest success factors for me in the progression of my career. So, take advantage of that and don't be afraid to reach out to people that you can't imagine would answer you on LinkedIn. Like if you go to a talk and someone inspires you or you see something online or an article written by someone on Medium, literally reach out to that person. You would be surprised. A lot of people in the technical community are very, very attuned to and want to support other people. So I would say take advantage of that, especially early in your career.
Those are some great recommendations. Rick, anything you'd add in your thinking?
Well, if you don't have a ChatGPT API key, then you're already behind. It's honest. It's almost it's almost just mind blowing. There's at least 1,000 new, GPT models every single week. I don't know if you follow it on Twitter, but I get literally every day I get a new readout of the new, and it's models on models on models, right? So it's Auto GPT to generate automated tasks against Chat GPT, God mode to provide another interface to create Auto GPT, I guess, and like that's a really interesting evolution. I think it mimics past evolutions of technology disruption in our environment. And so I can't think of a time that's more important to do what Danielle said, to be experimenting and learning throughout that journey and that process, because there's no textbook that can teach it to you, right? I love the idea of the data theory, the applied mathematics and statistics and data science, in part because it's inevitable that we'll have to provide more explainability around these models, and there's simply no way to do it without the understanding of the math. And I also think that there's likely to be an emerging role for people who specialize in linguistics and language. That's actually one of the most powerful and disruptive things that's happened with these transformer models, with these large language models, right? They're powerful because their ability to connect, synthesize, summarize language very specifically. Generate and understand language very specifically. And I think it's very likely that that explainability is going to come not only from math, but from keen understanding of linguistics, keen understanding of language, not just how it affects us, in society, but how it connects us as well.
Well, you both referred to, I got our last question here, you both referred to either Chat GPT, generative AI, and we've seen a lot of the big tech companies have had their earnings week the past week or two, and you've heard AI and Microsoft, they said it 50 times, and I think Amazon tried to push it in theirs, didn't help much today, but how do you think that this generative AI capability will really help organizations? There's a lot of speculation now, but I think you each probably have a set of use cases or thinking. How do you think this is going to really change a data-driven organization 5+ years from now? And any early things that you're seeing that you can share with the group? Rick, maybe start with you, and then, or go ahead, Danielle. Yeah, either way.
So I think the use cases are going to explode before they kind of contract and get filtered down. But it's in real world corporate environments, right? The number of people have grown of adoption, have grown at a rate of adoption that mimics the rate of adoption of ChatGPT relative to past technologies as well. So I think some of you have probably seen this chart. How long it took Netflix to get to 1 million users versus how long it took ChatGPT. We're talking the difference between years and 5 days, right? Well, it took about 2 weeks for some companies to reach thousands of users already accessing ChatGPT. And so what that means to me is that the applications are almost boundless, right? The number of places where it can get plugged in to enhance our productivity right now, without even training it any further, is not likely to be easily measured even from the smartest folks who kind of categorize these use cases and otherwise. So I think that that's going to create this really incredible opportunity. The ultimate question I think that is going to shape this, and I don't want to go to the downside risk, so to speak, too soon, but I at least want to get this out of here, is there will ultimately be a legal intellectual property question that gets decided, most likely at the Supreme Court. It reminds me significantly of about 2 to 3 years ago, there was a fight between Oracle and Google over the Java API. And the fight was, of course, whether or not it was a derivative work. And the models in question have been trained in many cases on copyrighted material and on open source software. So naturally, somebody who's smarter than me is going to have to decide, is that a derivative work? And what does that mean? Now, open source is kind of special, and since I'm in technology, I sort of stick there for a minute, right? Open source, sort of famously is built on the notion of, sort of this notion of steal this software, right? Kind of like after that, steal this book, mantra, right? And so GPL, the primary language for a significant body of open source, is what we call viral. It means any derivative work, by its nature, has to be part of the GPL license, right? Okay, so I just said there's 1,000 of these a week that are trying to commercialize on top of these technologies. It's not at all clear to me what that's going to mean over the long term. Right? So what I think it's important to experiment. I definitely think it's important to experiment at the edges of intellectual property, because I think the risk to intellectual property is very great, for exactly the reasons that I outlined. And I think anywhere where there's no such risk, where it's all about productivity, all about our ability to automate human tasks, the opportunities are almost boundless. They could be experimenting not just daily, but by the hour.
I'm going to use a very rudimentary example of something that I think will be interesting in another couple years, and it's around traceability, explainability, and lineage. So do any of you have teenagers or young children in school? Anyone? Okay. So they don't teach cursive anymore in school, at least not where I live and in the South. So it's a lost art, right? If someone was asked to, can you write this letter in cursive, children under a certain age will not be able to do that. So the metaphor I'm doing here is, if we use generative AI and the prompted analytics and the assisted way you're working, if it's doing it for you, over time people are going to lose the skill that used to be done manually. So where does the explainability go, right? what is the lineage? What is the provenance? And I ask people this all the time now. So when people produce material, or I'm, interacting with someone and say, well, did you use ChatGPT? What, to what degree is that changing the provenance and the lineage of our understanding of how you got, did you do the math, right? I think it's going to be really interesting. So I actually believe, this is just a theory, you guys can say you heard it here first, that there will be some sort of corrective insulation that has to happen where companies will have to prove the provenance of what came out of the model. I know that in the past I've seen engineers or people who were doing highly intensive data wrangling. They spent 40 hours a week doing data wrangling and very little time on actually looking at insights. When predictive models were put in front of them, or we were automating their work, they were very skeptical. And they said, I don't trust the model, not yet, right? And then over time, they would trust it, and then they would move aside their old Excel spreadsheets and access databases, and then they would rely on the model. And the benefit to them was, instead of doing 40 hours a week of data wrangling, they were doing 2 hours of data wrangling. And they were spending 38 hours doing data exploration and incredible work, but they still felt a need to know the provenance and the lineage of how that model was making their job easier. So I think there's this space of what's going to happen, how are we going to have some telemetry and some information that what if I do want to look back and see, where this data came from? What was this model trained on? I think there's a whole discipline that will emerge there, not just from the intellectual property standpoint, but just from the human understanding. You can't take the human out of the loop, you all know that. But I think that could be both from a privacy standpoint, from a legal standpoint, and just from a way of working that could potentially emerge.
No, I think that's great, good points you both made on that. I think this is definitely one we'll all keep an eye on, and it is disrupting, and it'll be interesting to see as organizations evolve behind it. So, okay, with that being said, why don't we move to, and I don't know how much time we have left, but we can go into audience Q&A. If there's any questions anybody has in the audience, we can give it a go.
Hello?
There we go.
Yeah. Maybe this is just an organizational question more like, but at the end, I think firms are still entities that are after profit maximization, and then although data is created to derive better informed decision of the big organization, but ultimately the main goal stays the same. And I was kind of curious, maybe this hinges on the discussion on data governance and also data quality trade-off maybe, but I was wondering what would be some efficient or like a good structure of the organization, even though the question that firms solve is still the same, but the dynamic of how they go about it changed because of the AI development and everything. And so maybe like an easy question would be, do you think horizontal structure or like a more like a vertical structure so that more supervision can be effective? I was just curious about what you would think.
Rick, I think you've spent a lot of time on this lately. Yeah.
I have spent a lot of time on this in the last 2 years. So Sandeep. Danielle knows a lot, I'm sure, from her time at Nissan as well. So first, all organizational design has both vertical and horizontal principles. So it's never a matter of one or the other. It's always a matter of degree, and it always matters what you're optimizing for, right? Now, with data, what we find is reusability is hard, right? Reusability, it varies at each level of the stack. So one way to think about it is the lower that you go in the stack, the greater the level of reuse, or the lower the friction to getting to reuse. So Danielle made this observation about observability, telemetry, and otherwise. Well, an infrastructure implemented once with strong telemetry and observability can be used many, many times as, in a utility way. So there's almost always some base of horizontal in those organizational designs. It's only a matter of how far up the stack they creep. Now, I happen to be of the opinion that to get the best advantage out of data, that you need a level of reuse that's higher up the stack than that. It's not only an infrastructure problem, that you need, in effect, data models, to reemphasize something that Danielle mentioned earlier, that are foundational in nature and that allow you to apply governance and allow you to be able to put a certain degree of a control environment and monitoring on top of that, after which time you can specialize and you can put data into more applied data science and other disciplines, right? So I believe strongly that in order to do that, you do need a certain level of a centralized organization in order to do that. But I think you also have to have data expertise. And data expertise is hard to develop if you're not in a mode where you're close enough to the business where you're learning it in applied ways. And so I think designing a model whereby you have some vertical emphasis, you have folks who are learning the data through their direct exposure to data scientists in those business areas is critically important. And then, of course, last but not least, I think you have two parts of the sort of overall data ecosystem or organization that are just as important, but that aren't so easily answered into sort of a single, box, which is one, you have data science and analytics and business intelligence that needs to be fast and responsive to so many different changing business needs that taking it out of the business, it comes at just too great a cost. Your ability to meet that is just very challenging to do, at scale and to do it at the speed of business today. The same thing is true with data governance, as we talked about earlier, right? It's important to have a data governance organization, particularly one that's sort of global in nature, one that's helping you set policy and standards across an entire organization. But data governance as an organization isn't actually how data governance is achieved. Data governance is achieved through the network of data owners and stewards. And those folks need to be the ones who are the line operators, the ones who are directly accountable for a decision whether to stop the line, whether they're the ones who stand up in front of the regulator, they're the ones who stand up in front of the client, because they ultimately have the decision-making authority and they have to work with it. So hopefully that gets at part of your question. There's no organization that's either one or the other. You need all three of those, I think, in order to make for a foundational data ecosystem that can be successful.
Danielle, anything you want to add? Or okay, sounds good.
So we have a couple of questions from the audience. One of them is, does your organization have designated team for model deployment and production? And do you hire ML/AI engineers for such team, who are they mostly computer science engineers?
It's a great question. So just everyone, make sure everybody heard is, do your organizations have MLOps engineering functions? That's something that Rick and I have been talking a lot about lately. And what sort of skills, experience are you looking for, engineering type, for that? So Danielle, maybe you can start and then.
Yeah, absolutely. It's very important. And I think it came with the maturing of data science in organizations where you had data scientists that were, doing the work over the last, 5 to 10 years. And then it would sometimes fall down, when you got to the ops part, because if you think about how operations normally is done in a large, or really any size company, someone has to be watching, right? Someone has to be watching for drift. Someone needs to be watching to see if things are breaking down. And because it is more highly specialized, it really does take, a specific skill set. I think that most of the engineering functions that we see, the diversity of those that are applying for those types of roles sometimes are computer science, sometimes are engineering of various types, data science. I think it's really around getting into the contemporary skill set of the tooling. It is a very technology-led, type motion, and it's changing a lot quickly with the advent of data observability tools, and again, things that are much more generative in nature. So I think if, my advice would be people who are interested in that lean into the tooling and really see, because it's being embedded now in all types of software, as before it was kind of a bolt-on or an add-on. I think it's much more integrated now into the software stack. So yeah, and so software engineers, are also a prime persona for that.
Yeah, and I think it's a great partner skill with the data scientists. As we've talked a lot about data science today, that's, I think, one of the most emerging functions we've seen. And I don't know, Rick, if you wanted to add anything else, but I think that's really something that I think is a really rapidly evolving role and skill set.
Yeah, I like what Danielle had to say. The only thing I'll add on top of it is ML ops and engineering is often the difference maker between whether or not you can deploy a model quickly enough to capitalize on the business opportunity. We know that. We measure it. We know how long it takes for different companies to deploy models into the production environment. And the model often is deployed in a way that it changes the way we interact with the app on our phone, or changes the way that we interact on the web, or anything else. And so it needs to be deployed at scale and very quickly. So that discipline has, I think, emerged, as Danielle rightly pointed out, honestly, as the number of models proliferated so rapidly that there wasn't enough life cycle management, wasn't enough operations discipline in place to manage the environment. So anyhow, I think that's why that is such an important role, and I do agree that it's primarily a CS role as a background, though not exclusive. So there's other engineering disciplines that I think that are equally relevant as we look at that. But I think it's a great question. It is very important.
Yeah. Do we have any?
Thank you. Actually, my wife wants to ask this question. I have some other questions, but I'll let her question to go. And it's both for Rick and Danielle, please. UCLA has just added, they had the data theory major, and they just added data science major, basically kind of going in parallel. And I don't know, maybe you know more about that. But the question is, given pretty much graduating student with one degree or the other, what would be your preferences in hiring, considering equal GPA, equal number of hackathons participated, blah, 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 all these activities, and maybe also from perspective, Rick, you work for an organization, kind of end organization, you work for a consulting organization, so if that would also kind of have any impact on what your answer would be, so please let us know.
Obviously the curriculum, depending on the role that's being filled, would be a driver. So depending on the details of the curriculum, that might be a factor. But actually, I think the technical skill of the individual, and many organizations do a lot of testing and vetting, of the ability for people to actually write code, to deploy code. So I would say technical competence is important regardless. I wouldn't rank one of those two, over each other. I actually think that it's what I call the whole package. So ability to communicate, both from a technical perspective and from a business perspective. I think the basis of good practices for product management, for understanding the software development lifecycle, that could be with either individual. So I think it's more around the holistic person. I will say I place a very high emphasis on cognitive diversity and people who are problem solving in creative ways. So, whatever major it may be, if the person in that discipline is finding unique ways to solve problems and is innovative, I think that's what we look for as a firm, because we do incubate so many, leading edge technologies and things like that. So we look for that critical thinking as well. But I think I look at it holistically, not so much a difference of one major over another. But sometimes curriculum does matter if it's a really specific discipline that we're hiring for. But either way, I think the whole package is really important.
I agree. What did UCLA's admission rate get to? It was 6% on on 150,000 applicants. Was that what I read? Better than Cal. Was that a win around here? I don't know.
There is some competition.
There's a little competition. So in practice, I think exactly what Danielle said, right? Unless you're in a highly, highly specialized field where the discipline that you're hiring for is sort of deep in the mechanics of the model, then I think it's that well-rounded applicant that's largely going to be the most attractive in many industries and many different applications. And I think you can be well-rounded in either one of those disciplines. I do particularly believe that, you know, that the additional emphasis on math is helpful, in particular based on my theories about where the market's going. Now, the practical reality is there simply aren't enough data professionals and candidates today to hire, right? What was the economics report? I think it was, we're at about 1.5 jobs at least for every applicant. I think that's what I heard on the GDP you know, report that came out today. And in data, I would basically say that that's no less than triple.
Yeah,
It's probably much closer to 5 to 6 jobs per available applicant. And so, you know, in some respects, there's not much you can do to go wrong. You're already in UCLA. You're choosing between two very highly, you know, disciplined fields. And I love everything that Danielle had to say about some of those additional qualifications and attributes that you're looking for in that well-rounded candidate.
Yeah, and maybe I'd just add, I know that the program does like practical real-world experience as part of the program, but I would say doing an internship, getting real-world experience, that will help dramatically as you kind of look for the career. That's just getting the practical, and I think the communication skills Danielle emphasized, that's what we look for. So that's how I'd emphasize those other aspects. How are we doing on time? Any more questions that we have, or one more? Time for one more?
Hello, thank you. This is kind of very similar to what you were talking about, but in terms of like how fast like the market is changing, it almost feels like once you learn a certain topic, right, and by the time you can finally enter the professional field, it's felt like it's become a little obsolete, and I feel like people have tried to remedy that by bringing like technological education like earlier on. But then I'm thinking back to like I was learning Excel in 3rd grade, and once I get out there into the professional world, I'm more like it already feels like more of a history lesson versus something that I'll be able to use in like my professional career going forward. So how do you think it's best to pursue that kind of becoming that well-rounded candidate, whether it's like the internship or focusing more on like learning how to learn in terms of problem-solving skills, if it rather than just like taking a specific programming course that, you know, by the time you graduate has already like become more or less obsolete?
You want to take that, Rick?
So I want to challenge a little bit of your thinking about obsolescence. And in part I want to go back to some themes that I mentioned a little bit earlier, that transferability, fungibility, your ability to make, you know, connections in your career as you progress is very much going to be based on your experience, right? Regardless of where it is. And so Excel, we already talked about it a little bit, it trains you to think in a certain way, and that has wide application in a variety of different fields. A data frame in Python is essentially a grid in Excel, right? Like at its heart. Okay, so first off, I would say I truly don't really believe any skills are fundamentally obsolete. I mean, certainly there's certain, you know, kind of very manual tasks and otherwise that are obsolete. But so then the second thing is what's the average that you'll change 3 times in your career over the course of your career? So then maybe the second message is, don't worry about it too much. You're probably going to be wrong the first time anyway. I was, right? Okay, that's too flip though. I don't mean to reduce it down to what you're saying. So I think what that does go back to is accelerate experience, pull forward anything that you can do to gain actual experience, particularly experience that enables you to sort of try new things and fail. I think internships are perfect for that. You know, they often put you in an environment where you're not working on the most critical thing, but you're learning new things in a business environment, particularly how to communicate with others, because half of effectiveness in the business environment is how you're able to work with others. And so almost anything that you do to pull forward that experience and to begin working with others on a more and more of a scale is going to be beneficial for you. And then if you have a reasonable enough cross-section of skills that you've built, whatever they may be, both Danielle and I can tell you, we've repurposed our skills in various technologies and various disciplines over and over again throughout our careers. Trust me.
Yeah, I mean, my view on this is be a voracious learner. So there is so much available to you in the public, you know, like if you are on Medium or you get on LinkedIn and you follow, you know, I would follow progressive, innovative people that are closely plugged into product teams and product engineering for the newest technologies. So AWS, Google, Azure, you know, people who are founders of data integration companies. If you follow those people, you're actually going to have those early awareness of the newest technologies that are emergent. There are many organizations that are publishing matrices of, these are the big players in data management right now. These are the big players in programming. Read those, follow them, and then actually pick a couple, you know, and start exploring and tinkering, especially since most everything is API based as far as, you know, free login, you get so much compute using this API, and do tinkering, you know, as much as possible with the new technologies, because then you're sharpening the saw all the time, right? You're staying, you know, really have a good idea on what's new, and then you can kind of get spatial awareness of what the next big thing is. I mean, particularly now with generative AI, but don't limit it to that. I think that that's a really good way to keep yourself energized, especially let's say you're in a role, you know, you're in a job and maybe you're not growing, or you don't feel like the role that you're in is where you want to be, you know, in a few years. You'll get some leading, you know, cues from your discovery and your exploration. And there's just so much information out there. So I would say, you know, if you're a voracious learner and you really look at the technologies that everyone's talking about, that'll set you in the right direction. So.
Yeah, maybe I'll just add one last thing before we wrap it up. We're asking our data scientists within my team to continuously learn new tools. We're introducing new tools into the ecosystem. We're asking them to learn new programming languages, methods, ways of thinking. I think that's just a natural part of progression. And so I think the voracious learner comment struck me, is that you have to just continue to roll with it. So. All right, well, thank you. Thank you, Danielle, and thank you, Rick, for the time. I think, Mark, you were going to come up and close us out, or? All right.
Actually, my closing out is very simple. That was fantastic, and I think we should give the three of these a big round of applause.